Black holes are extremely dense objects in space with an incredible gravitational force that distorts space and time all around it, making it pretty much invisible and not letting anything escape it.
How do black holes emerge? According to the NASA Science article, the majority of black holes form from the remains of large stars that die in a supernova explosion. As the large stars die, it leaves behind a small dense remnant core. When the core's mass is more than 3 times the mass of the Sun, it results in the force of gravity overwhelming all other forces and creating a black hole. Additionally, larger black holes usually emerge from stellar collisions. Supermassive versus stellar mass black holes. Supermassive black holes are known for being immensely large. Moreover, supermassive black holes are millions, if not billions of times as massive as the Sun. Astronomers infer that supermassive black holes are located in the center of virtually all large galaxies and in the Milky Way. Stellar black holes are the remains of large stars. Stellar black holes are typically 10 to 24 times as massive as the Sun. Stellar black holes are known to be challenging to detect. Scientists infer that there are at least 10 million to a billion stellar black holes, only counting the ones in the Milky Way.
The distance between the center of a black hole and its event horizon is called the Schwarzschild radius. To find it, you need to multiply 2 times the gravitational constant multiplied by the mass of the black hole divided by the speed of light square. On the bottom left is the actual equation besides m. Doesn't just have to be for a black hole. It can actually be anything from a computer, a school bus, to the entire planet. This means that theoretically anything can become a black hole so long as it is crushed down enough to the point that it actually gets a Schwarzschild radius. For reference, here's a black hole where that dot in the center is called the singularity, also known as the center of a black hole. And the blue dotted lines is the edges of it, the event horizon. And between them is the Schwarzschild radius. The size of the radius depends on how much mass is in the singularity. So for black holes like this, it'll be larger, but it depends on the mass of the black hole. So for those with smaller masses, it'll look something more like this, or even smaller.
The effects of black holes. Recent discoveries reveal black holes have the ability to release powerful gamma ray bursts, devouring nearby stars and spurring the growth of new stars in some areas while stalling it in others. Gamma ray bursts are powerful fleeting flashes of light.
When the core of a very massive star collapses, forming a black hole, the material just outside the core falls down, forming an incredibly hot swirling maelstrom called an accretion disk. The magnetic field of that material, and from the black hole, coil around, wound up by the rapidly spinning disk, pointing up and down out of the disk and away from the black hole. The details still aren't entirely clear, but this launches twin beams of matter and energy up and away from the black hole.
So just in case you don't know, getting near a black hole is extremely dangerous. If there's an accretion disk around it, it'll be astronomically hot, as in around 4,000 degrees Fahrenheit. If you go past the event horizon, you're eventually going to get spaghettified and then crushed, or get hit by gamma bursts, which is a bunch of radiation. So in general, you're just going to die. Here's a quick video of spaghettification.
Trouble. As you fall in, your feet are pulled so much harder than your head that you stretch, pulled like taffy. You'd become a long, thin noodle, kilometers in length, but narrower than a hair wide. Astronomers call this, and no, I'm not kidding, spaghettification. This would happen pretty close to the black hole, just a few dozen kilometers out.
When two black holes meet, they eventually combine into an even larger black hole, which causes an incredible amount of gravitational force around them. However, this takes billions of years, since they don't actually smash into each other. They actually spin around each other until they collide, which also causes a gamma ray burst because of the incredible force.